So today, I'm going to be building an inverting amplifier. And here's the screenshot for this inverting. Actually, you know what? Before I do the screenshot, I should read the thing. Now I've got it working in Tinkercad, plus 22 to negative 22. I can prototype an inverting amplifier that should have come in the build cycle. Below is an image of a textbook inverting amplifier with a 1.5 volt battery and various resistors and an op amp. Prototype it, and we're going to get 10 times amplification. That means with our input is 1.5 volts, we're going to get 15 volts on the output. But because this is an inverting amplifier, we're going to get negative 15 volts in the output. And that's why we needed this negative 22 here, so that we have the negative space, I guess I could say, to do that. So I'm going to need Tinkercad. I'm going to need a 1K resistor, 10K resistor. This was really simple and straightforward. So I'm going to start with my Tinkercad, and I've got this set up with this power supply at 22 and this one set at 22, but I've reversed the polarity here, and that gives me negative voltages. I've got my 1.5 volt battery here, and I've got a meter so that I can see my end result. I've got my op amp, and I've already powered it. You see power plus is connected to the plus here, and power minus is connected to the plus on the other side, because that plus there is actually negative 22 volts. So let's get busy simulating this thing. First thing I'm going to do is take my battery here and connect it to ground, right? That negative one there. We got common ground that we're going to do. So I connect that negative one to ground, and now this positive one, where am I going to go with that? Well, looking at the circuit diagram, I'm going to go through a 1K resistor into the inverting pin on my op amp. So I have a 1K resistor here, ready to go. And where's my inverting pin? If I wave over it, there's the inverting pin. So I'm going to put it there, which means this is where my positive 1.5 volts from the battery is going. So I'm going to come dip down here, right to there. Boom, that's connected. So now I've got that first bit where that goes in. I now need my amplification, which is going to be a 10K resistor over the top, connecting the inverting terminal to the output. So I need to put a 10K resistor up here, because the gain that I get from my inverting amplifier is this resistance divided by this resistance. So 10 divided by 1 is 10, which is where I get my 10-fold gain here. So I'm going to have to sneak around from one side of the board to the other so that I can connect this 10K resistor to the output. So from the negative terminal here, I'm going to slide over to my 10K, and from my 10K, I'm going to slide over to the output. So what that gives me is this bit over the top of the circuit here, where the 10K connects the negative or the inverting input on my op amp around to the output. The only thing I need left here is to take care of my non-inverting input, which is just simply connected to ground. So I'm going to go here to the plus terminal here, and I'm just connect that to the nearest ground, which is right here, negative. Notice I have that this wire over here that connects the negatives on both sides. So I have the common ground all the way around the board. So there's that negative. Now, if I connect my meter to this and run the simulation, what I should get is negative 15 volts exactly. Let's see how it goes for me. So I connect the negative terminal of the meter to ground, and I'm going to connect the positive terminal of the meter to my output here. And I'm going to start the simulation, and hopefully things will start going my way, because I've been struggling with the Tinkercad recently. Start the simulation, negative 15 volts on the money, the inverting amplifier.
Mm-hmm.